Assalamualaikum. Hi everyone. Today I want to share a topic entitled probability space, probability density and definition of expectation, means and variance. So, let's start with what is probability space. A probability space is a measure space with total measure 1. The standard notation is omega, math call and p. What is the symbol mean?
Omega is a set which is sometimes called sample space. Its elements are denoted as omega, which sometimes called outcomes. F is algebra of subset of omega, where set in F are called event.
P is a function domain F, range of subset 0, 1, which is satisfying the equation 1 and equation 2 below.
What about discrete probability space?
It is a probability space such that omega is finite or countably infinite. In this case, we usually choose F to be all the subset of omega, and the probability measure P is given by a function above. Probability density function. It is a continuous random variable takes on an uncountable infinite of possible values. For a discrete random variable x that takes on a finite or countably infinite number of possible values, we determine p x large equal to small x for all the possible values of x. For continuous random variables, the probability that x takes on any particular value x is 0. That is, finding probability x equal to x for a continuous random variable x is not going to work. Instead, we will need to find the probability that x falls in some interval a, b. Probability density function is written as fx. This function is defined over the range negative infinity to infinity. The x can be determined as continuous random variable if it has the properties as following. There are some examples of continuous random variables. This graph indicates the area give probability within the range of a and b. Area under the graph is denoted as P. X is larger than A but is lower than B, and the curve is denoted as a function y equals to fx. Next, let's move to the definition expectation of means. The expected value of random variables is the theoretical mean the random variables. It is not based on simple data, but it is based on distribution of random variables. Expected value of means is parameter, not statistic.
Now, let's move to how to calculate the means. Expectation of function gx. For some function of random variables, gx could be x squared of the square root of x or log x. For continuous random variable, we take the value of the function, multiply them by probability of those values occurring and add all at the last. Next, properties of expectation.
Let g and h be functions, and let a and b be constant for random variable x discrete or continuous. The formula are shown as below. Let x and y be any random variables, discrete, continuous, independent or non-independent. Then the formula are as shown below. Exy equal to ex multiplied ey are only true if the x and y are independent random variables. Next, probability of expectation. Let A be any event, we can write PA as an expectation as follows. Then IA is a random variable. Then PA equal to E IA for any event A. So, the expected value for the example given can be obtained by multiplying the possible value with the corresponding probabilities. Variance is the spreadness of how far the values of x are from their mean or average. Variance is mean squared deviation of random variable from its mean. If x has high variance, the x values is a long way from the mean. Properties of variance. First, let g be a function and let a and b be the constant for any random variables x, discrete or continuous. Second, let x and y be the independent random variable. Third, if x and y are not independent, covariance is a measure of dependence between two random variables x and y. Variance are always positive, meanwhile covariance can be either positive or negative or even zero.